Okay, welcome everybody. Today I'm going to talk to you about understanding chemical reactions and the types of reactions and how to balance them. So the first thing I want to talk to you about are reactants and products in a chemical reaction. And when I draw out a chemical reaction, I'll generally have something like, let's say H2 plus O2 yields H2O. And some of you that are looking at this are like, well, there's a different number of oxygens on each side. That's weird. So I can balance it just for effect here, and we'll talk about how to do this. But there's my balanced equation. And so you should know that highlighted in blue here are my reactants, and highlighted in pink are my products. And so my reactants are in blue, and my products are in pink. And we can do that here, products. And again, reactants we can do in this blue color over here. So you should know that on the left side you start with reactants, on the right side you end with products. There's an arrow that goes between the two that's showing that there's a chemical reaction that's taking place. Now, the next thing that's important are coefficients. So coefficients, these are the numbers in front. And these could represent one of two things. They could represent the number of each substance. And so I could read this as 2 molecules of hydrogen react with 1 molecule of oxygen to form 2 molecules of water. Or more commonly, they represent the number of moles of each substance. So I could read this as 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. So that's what the coefficients stand for. For the subscripts, those are the number of each atom in a substance. So if I have, H2, that means that I have 2 H atoms. And what we'll see is that we multiply the coefficients times the subscripts, and we get the total number of atoms. So on the left, we have 4 H atoms. And on the right, we have 4 H atoms. On the left, we have 2 O atoms. And on the right, we have 2 O atoms. Notice that I leave out the 1 in front of O2. Although the reagents will accept that, it's generally frowned upon to put a 1 there. If there's no number in front, it means that you have 1. Now the phases I left out, but the phases are solid, liquid, aqueous, and gas. And so here, for example, hydrogen and oxygen exist as gases, so I put a little G down here, and the water that forms will form as a liquid. This shows the phases. Now, when we balance an equation, we want all of the equations to occupy or obey the law of conservation of matter. So the light just went out. Let me go turn that back on and continue. So the law of conservation of matter, it says that the mass of the reactants must be equal to the mass of the products. And we're going to illustrate this by having the same number of atoms on the reactant and product sides. And notice I went through that equation above and I said, oh, there's 2 H atoms and 2 H atoms. There's 2 O atoms and 2 O atoms. And the way that we do this is by balancing the equation. And so this is going to be done by balancing an equation. And what we do is we basically multiply. We multiply the coefficient by the subscript. Now something that's important is that the coefficient goes for the entire atom, or entire molecule. You can almost think of it as there being a fake parentheses or an invisible parentheses around the entire molecule, and the 2 or the 3 or the 1, whatever's in front, will be distributed throughout. So now what I can do basically is balancing by inspection. Let's say I were to take something like N2 plus H2 yields NH3. And the first thing that I'll do is I will pull out the elements that need to be balanced. So I'll be like, all right, well, I have N and I have H. Those are my two elements. And I'll go through and I'll do my multiplication here. And I'll say, well, there's a 1 in front of the N2, so I'm going to do 1 times 2. So I'm going to have 2 N's. And there's a 1 in front of the NH3, so I'm going to have 1 N. And there's a 1 in front of the H2, so I'm going to have 2 H's. And there's a 1 in front of the NH3, so that one gets distributed. I'm going to have 3 H's. And there's some balancing issues here. It's not working. So let's try and balance the N's. I would need 2 N's, so I would need to take out this 1 here, and I would put in a 2. And now I would have 2 times N is 2. But now my H has changed too, and this is where people get a little bit frustrated because now things are changing. So the H changed. So I have 2 times 3, I have 6 H's. And so now I need 6 H's on the other side. If I put a 3 in front, 3 times 2 would give me 6 H's. And now I just do a quick run through. 2 N's on the left, 1 times 2 is 2. 2 N's on the right, 2 times 1 is 2. On the left, 3 times 2 is 6 H's. On the right, 2 times 3 is 6 H's. So I have balanced equation, I'm done. I have the same number of atoms on each side. If you were to add up the mass of each of these, just to give you an idea here, and we'll do this in red, N2 is 14 plus 14, that's 28 grams. 3H2, so H2 is 2, times 3 is 6 grams. And on the right here, we have NH3 is 17, times 2 is 34 grams. Well, look at what happens. At the side here, what you can see is that 28 plus 6 should equal 34, and it does. And the Regents likes this question. They'll give you 2 out of the 3 and then ask you to find the other one. Okay, tricks to balancing equations. So sometimes equations, they're not so easy to balance, and they require you to be, a little bit savvy with this. One example is when I have something like a combustion reaction, something like C2H6 plus O2 yields CO2 plus H2O. And we'll talk about this type of reaction. It's called a combustion reaction. You'll have to know that this is a combustion reaction. I'll show you how to recognize it. But now I go through and I say, oh, I got C, I got H, I got O. One trick right off the bat that I do is I'll look at this and I'll say, well, the O is split between 2 compounds over here. I don't want to deal with that until the very end. So I'll do my C and my H first. 2 C's on the left, 1 C over here. So 2 and 1. So I'm going to put a 2 here right now. That'll give me 2 C's. 6 H's on the left, and then 2 H's on the right. So that's 6 and 2. That's not going to work either. I'm going to need a 3 there. Now notice, I'm going to do the O's now. So when I go ahead and I do the O's, I'm going to have 2 O's on the left. And on the right, I'm going to have 4, and I'm going to have 3, I'm going to have 7. And now my heart breaks because it's not an even number. There's no, thing that's going to help me with this. And so I cheat. Here's the trick. What times 2 would give me 7? That's the trick. Well, I cheat a little bit here. I'm supposed to use whole numbers, but I use a decimal. I do 3.5. Now that 3.5 there, that gives me 7 O's, and I'm balanced. But the problem is that I can't leave it like that. On the Regents, they want whole numbers. So what I'll do is I'll double everything. This is where my second part of the cheat comes in. I'll double. So I'll put 2 here. I'll double this. I'll make it 7. I'll double this. I'll make it 4. I'll double this. I'll make it 6. And now we can check. On the left, 4 C's. On the right, 4 C's. So 4 and 4. On the left, 12 H's. 2 times 6 is 12. On the right, 6 times 2 is 12. So 12 H's. On the left, 7 times 2 is 14 O's. And on the right, 8 and 6 is 14 O's. So now we have our fully balanced equation. 2C2H6 plus 7O2 yields 4CO2 plus 6H2O, and we're fully balanced. So sometimes a little trick goes a long way and it helps. Now, let's say that I have something with a polyatomic ion in it, and this is where knowing how to name compounds becomes important, because I'll give you the names and you'll have to write the formula. Something like if I were to give you, aluminum, plus sulfuric acid yields aluminum sulfate. So now knowing how to write that, so that would be 2 and SO4, 3, and hydrogen gas. This is called a single replacement reaction. So now look at what I do. Instead of tearing apart the S and the O, what I'll do is I'll keep it together as a polyatomic ion. So I'll have Al, I'll have H, and I'll have SO4. That cuts things down a lot. I have 1 to 2. I have 2 to 2. I have 1 to 3. So now I'll look at this, I'll be like, all right, I'm going to start with whatever. I'll start with the SO4s. So I'm going to need 3 of these. That messed up my H's and made it 6, so I need 3 of these. I still need to balance my ALs. I need 2 of these, and I'm done. So those are 2 common tricks that you need to know. Now look, I'm going to stop here. This is plenty of stuff for one day. In my next video, which I'll do on Monday, I will do, or next week, I will do types of inorganic chemical reactions, thrown in with a twist of combustion in there, so you get to see that one. That one's technically an organic reaction. So really what you need to know from this particular video, you need to know the parts of a reaction, and you need to know how to balance a reaction. All right, thanks for watching.